Okay, so I want to quickly go over the most common mistakes from Section 1, Chapter 1. And the first most common mistake was not defining these sets of numbers really well. And they're really simple. Counting numbers, right? Recall, you make a bracket, and they start at 1. 1, 2, 3, ... meaning that this pattern continues forever. Close the bracket. That's the set. The whole numbers, you could say they are the same thing, only they start at 0. 0, 1, 2, 3, whatever, ... close the bracket. The integers, you could say they are the positive and negative whole numbers. That works. Or you could just say, you could do this. ... -2, -1, 0, 1, 2, 3, ... You could do it that way too. The rational number is any number that can be written as a fraction. Like, 1/2. Even 3 can be written as a fraction, 3/1. Irrational numbers cannot be written as a fraction. And real numbers are any number on the number line, so that includes all these numbers because they're all on the number line. And the last problem I want to go over is problem 9 in the homework. And it says answer true or false. All whole numbers are integers. Well, if you know the definition of whole numbers, right? And if you know the definition of integers, ... -2, -1, 0, 1, 2, ... I think you can see that all of these are also these. So this is true. Now here's the one. All integers are whole numbers. Well, are all of these also these? And the answer is no. So that's false. Now, you only need one example to prove that this is false. How about finding one integer? Just pick one. Like -6. Well, is that also a whole number? The answer is no. So that's called a counterexample. And in math, you only need one to prove that something is true or false, right? All counting numbers are rational numbers. Yes, counting numbers, recall, right? 1, 2, 3, ... Close parentheses. 1 can be written as a fraction. 2 can be written as a fraction. 3 can be written as a fraction. So these can be written as fractions, so they're all rational numbers. This is true. All rational numbers are counting numbers. Well, rational numbers are numbers that can be written as fractions. There's a lot of them. I just picked one as an example, like 1/2. That's a rational number. Is that also a counting number? No, because the counting numbers are right here. There are some rational numbers that are also irrational numbers. No, that's false, because either it can be written as a fraction, like 1/2, or it can't, like pi. Pi is 3.14159, etc., etc., etc. It never repeats and it never ends. So you cannot write it as a fraction. You can do this. You think that's a fraction? No. A fraction is a integer divided by an integer. So 6/7 is a fraction. But 3.14159 over 1 is not a fraction. You can't make it a fraction. So these are the two major issues.